Okay, guys, for practice, we're going to do some graphical analysis with these graphs, and let's break them up using what we know about function behavior. Okay, so here in the first section, we're going to talk about how our function is increasing, decreasing, and where it's also constant. So if we look at the red section, the first thing we'll see is if you read from left to right, I know that arrow seems like it's pointing downwards, but our line is actually traveling up because we measure it this way. Okay, you can see I marked little arrows for you there. Okay, so I would mark that I have an increasing interval from negative infinity up until what looks like -1, and I'm going to mark that off with a parentheses. So again, because it's an open circle, I'm using a parentheses. Now, I have another section that is increasing from right here until this end right here. So that is going to be from 0 until 2. Okay, and again, I'm using x values only for these increasing and decreasing sections. And these are all open intervals, okay, which means they do not have any brackets. They must be only parentheses, okay? And these are x values. Okay, let's look at our decreasing section. So there's a small section right here that I highlighted, which will be our decreasing section. So we're going to be decreasing from, looks like -1 until 0. Again, I'm only looking at the x values, and I'm going to use soft brackets instead of hard brackets here. Okay. Now, finally, we come to our constant section. So constants have two major categories. So the first one is this spot right here in the middle at 0. Okay, at x equals 0, I should say. So I can say that at x equals 0, there is a constant. This point is a turning point. Okay, so anytime you have a graph turning point, that means that you're going to have a constant just at that one spot. Okay, now there's another section that is constant here, which is my green line right here. So that section goes from x equals 3 to x equals 5. So we're also going to have from 3 until 5 as our other constant section. Okay, so you get a constant when either you have a flat line or you're at that turning point. So at the turning point, we had x equals 0, and then our flat line was at from 3 to 5. Okay, so now that we've got our increasing and decreasing behaviors, let's take a look at that domain and range. So domain is going to be all of our x values. So if we look at our graph and we start following it from left to right, what we'll notice is I can start from all the way to the left. So -infinity along the x, all the way to here without ever having to stop. Okay. But because there is a filled in circle right here above that open circle, I can actually continue my domain without stopping. So all the way from -infinity until 2, my domain can continue without ever having to stop, okay? So we can write this as being from -infinity until 2, but just be mindful of the symbols I'm using here. Okay, so you're going to see parentheses -infinity and then a bracket on my 2, okay? So the bracket on the 2 represents that that point is a filled in circle. It is part of my graph, okay? Open circles would have parentheses. Now, that's not the end of my graph though. I still have a small section to the side, that green section, okay? Now that section picks up from 3, so I'm going to continue writing my domain from 3. So I'm going to say and 3 to 5, and those are both bracketed again. And the bracket again represents that those points had filled in circles. We can follow a similar process with our range, but we're going to go from bottom to top. So I'm going to start from here as -infinity, my lowest point. In my graph, I can trace it all the way up to looks like -1 on the y-axis. Okay, so let's go ahead and mark that first section in our range. It is going to be from -infinity until -1, parentheses for our open circle, okay? Then my graph will pick up from down here at 1 and go up to what looks like 5 at the top. So then my remaining portion of my range will be from from +1 until 5, and I'm going to bracket these because they are filled in points or points on my line. Now that we've got this part filled in, we'll go ahead and also take a look at our extrema, which is just a fancy word for minimums and maximums. So if we look at our graph, we'll notice that I have this downward arrow towards infinity, which to me tells me I'm not going to have any absolute minimums. Okay. However, this high point right here can be my absolute maximum. Okay, and that point is going to be at 2, 5. Okay, and that is my highest point my graph ever reaches, so I call it an absolute max. Okay, and there is another point here that's quite special, which is down here in the middle. I would call this point a relative minimum, and that's going to be at 0, 1. Okay, so we have those two as our maxes and mins here. Now note this point right here does not qualify as an extrema. Okay, so this is not a max. Okay, because it's an open circle. Okay, so open circles do not qualify for this at all. Okay, so here's what we've come up with right now. We have our absolute max at 2, 5, our relative minimum at 0, 1. Now, next up, we're saying what value does the absolute maximum occur for h of x, which is just a transformation of f of x. It is a vertical stretch by 3 and a shift right by 2. Okay, and so they're asking us for an x coordinate, so some number x equals. And I'm just going to transform the entire maximum that we have, and that absolute maximum will then give us the new x coordinate. Okay, so my original absolute maximum is at 2, 5. And what I'm going to do is I'm going to go ahead and say if I wanted to shift that to the right 2 spaces, I would add 2 to that x value. And if I wanted it to stretch by 3 vertically, I will multiply my y value by 5, or say by 3. And so when we do this, we'll get something like this, 4, 15, and that is my new max for h of x. So what does my x value come out to be? You can see here that it's going to be 4, and that's my answer, x equals 4. Okay. Finally, we have our last question, which is when is our function equal to 1? When is f of x equal to 1? So I'm going to look for an x value where this is true. So simply enough, I'll just make a quick line across at 1. And you can see there's only one spot where my line hits that 1 value. And that point is, again, 0, 1, that relative minimum of mine. You could have more than one answer here, but in this case, the only time that my y value is equal to 1 is when x equals 0. And just keep in mind that you could have multiple solutions here if your line perhaps crossed that 1 value multiple times. Okay. Okay, here's another good example of graphical analysis. So let's lead out with our intervals of increasing and decreasing. So in this problem, you see this first line segment that we have is going to be an increasing line segment. So I'm going to go ahead and lead out with that's going to start from, looks like -7 until 0. Okay. And I have another segment that's also increasing over here. So I'm going to label that as being from maybe 3.5 until 6. Now notice all my increasing, decreasing, still open intervals. These are all parentheses. Okay. And my section that is decreasing, we can see is down here. So that decreasing section is going to be from maybe 1 to 3.5 as my x values. Okay, and this function has only a single point that's a constant. It's this downward little dip here, and that's going to be at x equals 3.5. Okay, so again, this is a turning point, and that's why we list it as being a constant for just that one little moment. Okay, and so now let's go ahead and study some of the other behaviors here. How about the domain and range? So this function has two major pieces, and it starts from looks like -7, and you're going to see me use a parentheses here because of that open circle. So we got maybe -7 up until 0, and then I'm going to bracket that one because we've got that included filled in circle. And then the next section starts from 1, again an open circle, so parentheses, and I can follow it all the way until 6 on the x. Okay, again, a bracket for that closed circle. Now, my range, I'm going to go ahead and list my range as coming from down here. Looks like maybe that might be -3. And we'll go all the way up until, looks like 4. Okay. Now, I want to note, yes, if I just trace this side of my line, we wouldn't necessarily catch all of this if I traced it only up to here. But because there's another point right here, we can kind of trace it to go further this way. Okay, so we actually catch this point right here as my maximum value. Okay, and so that's why we go all the way up to 4, and it's going to be a bracket on the 4 and a bracket on the -3 in this case. Okay, because both of those are values that my graph actually touches, and that's very important. Let's go ahead and list our extrema. So where do we see extrema here? I see a high point and a low point here. Again, this one is an open circle, is not a minimum. Okay, so on this one, if we have an extrema, I'm going to go ahead and say we have a absolute max at 0.4. Okay, and what is looks like an absolute minimum at maybe 3.5, -3. And again, that's my estimate of where that point is, but you might have a slightly different number than what I came up with. Okay, so we're just left with our last piece here, which is find the value of f of -6. Okay, so in this case, we know that this is our x value. Okay, so if that's my x value, let's just come back to our graph and find where my function is when x equals -6. So I'm going to come to -6, and I will just mark it right there. And you can see I'm touching this point, which looks to be at maybe -2. So we get this coordinate -6, -2. So what is f of -6 equal to? I would say it equals -2. Okay. And so that's just some basic graphical analysis, guys. We threw in a little bit of a touch on transformations as well. But mostly, guys, pay attention to the details of whether you have brackets or parentheses because of open or closed circles. Make sure that your increasing, decreasing, and constant intervals are all parentheses because they're open brackets. All right. And if you're careful about these little things, you'll do really well in this section. Okay. Good luck and happy studying.